Hi all, I'm Linnea Olivares, Chair of ASGCT's Communications Committee, and you're listening to Sound Bites of the annual meeting, our mini podcast series recorded live here at ASGCT 2025 in New Orleans. And I'm so excited to be here today with Dr. Kiran Musunuru, who needs no introduction, but I'll give you all his amazing affiliations anyway. The Barry J. Gertz Professor for Translational Research at the University of Pennsylvania's Perelman School of Medicine, where he leads groundbreaking work in cardiovascular and metabolic gene editing. He's also the director of the Genetic and Epigenetic Origins of Disease program at the Cardiovascular Institute and scientific director, the Center for Inherited Cardiovascular Disease. Get all of them?
Yeah, good enough.
There's probably a few more in there, huh? So thank you so much for joining us, Dr. Musunuru. Congratulations on the news yesterday. You've had quite a year. And of course, everyone listening probably knows that his team just published a landmark case in NEJM, the world's first patient-specific in vivo gene editing therapy for a child with a rare metabolic disease. So, like I said, most everyone listening will have heard about it, but I wanted to ask you, is there any aspect that you want to highlight that you feel has been underreported or that you feel like has been missed in the flood of news?
Sure, I think most of the stories that are out there, and there are quite a few stories, believe me, like I'm shocked by how much attention it's gotten, have focused on the positive, right? Yeah. And, present this as a big advance, which, I'll agree, like even though I'm involved in it, maybe it's a little bit self-centered to say so. It's like, yeah, I'm a little biased. But I think it's important. And so they focus on that aspect of it and the fact that it was done in 6 months, and that is, as far as I know, a world record time to make any sort of therapy in this way and get clearance from the FDA or regulatory authority to actually go ahead and give it to a patient, much less, a gene editing therapy where there's no precedent for doing this kind of personalized therapy. And so a lot of focus on that part of it without necessarily appreciating, the underbelly of it, by which I mean like any effort like this is going to have its ups and downs, right? And we certainly ran into obstacles. We were in a position, and when I say we, I do have to very, very, very much, acknowledge and really express my appreciation for my compatriot, my partner in crime, whatever you want to say, Dr. Rebecca Ahrens-Nicklas at the Children's Hospital Philadelphia, CHOP, with which I'm also affiliated. I guess we missed that affiliation at the beginning of the list, but that's fine. Who was my equal co-partner, co-conspirator in all of this. So whatever credit accrues to me, just as much, if not more, should accrue to her. But we have been in the fortunate position, well, maybe not fortunate, maybe it was deliberate, of doing a lot of practice runs in the sense that we took known genetic variants and sort of did time trials. We asked ourselves, okay, she would give me a variant and say, how quickly can you solve this in the laboratory? And so we would work. And, the first time we did this, it was like a year and a half. It's like, okay, that's great, but that's not going to be able to help our patients. And so we kept working at it, and we got streamlined. The second time was a little shorter, and the third time, even shorter. And after several of these tries, we got it down to a very short time. And so we de-risked the approach, I guess you could say, by doing all these trials. And, we'd been doing this for something like a year and a half before KJ was born. And we actually felt we were in a position to actually do it for real when KJ was born. And the timing for him was fortuitous. I mean, if it had taken us longer to get to that point, it would be a different patient. So I need to emphasize that KJ is a very, very, very special boy. Like, there's no question about it. But in a way, he's not special in the sense that if it hadn't been him, it would have been someone else, right? The whole point of this is that we want to be able to personalize for any patient, not just the patient who comes along who has the perfect variant, the right disease, or anything like that. Because that's the old way of thinking, right? We want to be able to help every single patient who comes our way. We can't yet. It's very good that KJ came along and we were able to help him, but it wasn't a given. But we had anticipated, prepared, and were in a good position when he was born to immediately spring into action and start working. And things actually went pretty smoothly. So I said the ups and downs, and sure, in a technical sense, we actually did a pretty good job. Like, we didn't have many downs. Like, things largely worked. A lot of the credit goes to my graduate student, or I should say the graduate student in my laboratory, who did the lion's share of the bench work, Sarah Grandinetti. Believe it or not, she's a third-year graduate student. She was the one person in the lab on this project. It was not an all hands on deck thing, as you might very reasonably expect. It was just her working, I wouldn't even say around the clock. She's just very, very good and can get things to work the first time. And so she powered through and got all the studies we needed done in a 6-month span. There's a lot of other moving parts, a lot of, like other academic partners and industry partners, and I won't go into all those details in the interest of time. So it was by no means wasn't my effort or Becca and my effort or Becca, Sarah, and my effort, but it was a large, technically an international consortium of people because there was a company in Canada involved. But having said all that, there were some really, really stressful times, okay, that were inevitable. And so let me give you an example. The drug was made, or at least the toxicology batch, the first drug. We ended up making 2 batches, one to do safety studies and then one that was the actual batch of drug that was administered to KJ. So the toxicology batch, we did a lot of the earlier studies because it was made first. And a very important key test was actually putting that drug on cells in a dish and then seeing whether we got the desired editing. And you might say, okay, what's the big deal? You have a drug and you put it on cells. Like, technically, it's a very easy experiment. Like, you can't really mess it up. But are you absolutely sure that drug is going to work when you put it on the cells? Like, you may be very, very confident, but you don't know for sure until you do it. That's why you do the study. That's why you do the experiment. And so for me, that was an incredibly stressful night. And I say night because Sarah had done the analysis. She had harvested cells, DNA, PCR analysis, all the fun technical stuff, and had loaded on the next generation sequencer. And so it started that in late afternoon, early evening, and it runs overnight. You get the data the next day. Except I was so anxious about, did it actually work? Did we actually get sequencing? I didn't sleep, and so I was just watching. Okay, how much longer till the machine is done? I think it finished at like 2:30 in the morning, and I was ready for it. Like, I was not waiting an extra 60 seconds. As soon as it was done, downloading the data, start analyzing. I'm at home; it's all done remotely. So, the moment of truth, and I'm praying to every data you can imagine, like, and more. Right? Just like, please work, because if it doesn't work at this stage, like, the whole thing falls apart. Right? That was the hazard here. So many things had to go right. And if any one thing went wrong, the whole thing falls apart. And so it's like the moment of truth. I press the button and it's crunching the data and I'm just waiting for it to spit out the final answer. And I see the final answer and yes, there's editing. Oh my gosh, it worked. The drug is actually, at least on cells, right? So that was like the first thing we had to get through. Huge relief, very, celebration the next day. Took the lab out for ice cream, which is something we do when there's, any even small laboratory, because we just like ice cream and we'll take any excuse to go out for ice cream. But then we went through all of that, or at least I went through all of that again several weeks later when we used that batch of drug and put it into a mouse model. So that's even more a moment of truth. Like, putting it on cells in a dish, that's... it's going to contact the cells and it's going to get to the cells, whereas you put it into a mouse model and these drugs are finicky lipid nanoparticles. Like, if they're not formulated exactly right, then they won't actually make it into the cells you want, deep in the body and the organ that you want, in this case the liver. So same exact thing, right? So Sarah does the work. She harvests genomic DNA and does it all and does it very well, as she always does, and then loads the machine. And again, it's like, okay, I'm not sleeping tonight, even if I want to, because this is like taking that to the next level, because the risk of it not working is even higher. And so the same amount of anxiety, if not more, like, am I going to see editing in the mouse? And then, same thing, and waiting for the data, downloading it, analyzing it, pressing the button, and yes, there was editing. Oh my gosh, right? So, okay, we're in business, I think, because at least it's working, right? Yes. You don't really know what will happen if you put it in the human being, and you won't ever actually know, right? Because even though we treated KJ, we actually ended up giving him 3 treatments to give him the best chance of efficacy while keeping the doses low for the sake of safety. And he did have some benefit, I think. It's hard to know. You're comparing it against himself, and even more than that, you're comparing him against himself if he hadn't got the treatment, which is, contrafactual. Like, you don't really truly know, like, what you have done in this situation. Ordinarily, you would need to treat a lot of patients, do a randomized control study, and things like that. But we sense that he got benefit, right? But we don't actually know how well it worked in his body because we're not able, or at least not ethically, it's not ethically acceptable to do a liver biopsy on a kid like this who we think has a normal liver. Like, you really have to have some serious evidence of liver disease, like liver cancer or some suspicion of liver cancer, cirrhosis or whatnot, to do a liver biopsy. If you don't have that, you can't just take a look-see and do an invasive procedure right now. So everything has to be inferred, and he's doing well. He looks great. I mean, like, his pictures, like, in every newspaper in America, it feels like right now. So he looks great, and he's gained a large amount of weight. Before he treated him, he was at the 9th percentile body weight for his age, and now he's like at the 40th percentile. So he's like gone through this huge growth spurt, just caught up, right? I mean, like, he was really undersized. He wasn't getting enough protein because if we gave him a lot of protein, like, it would turn into ammonia that would build up in his body and cause injury to his brain and potentially be fatal. So that was a no-go. But after the treatment, we could give him a full amount of protein, and he just thrived, and he's doing really well. So there's indirect evidence of efficacy, but we don't really know for sure. But man, oh man, when we actually got the data from the mice, it's like, okay, there's editing, so there's a good shot that, good chance that if we put it in KJ, that might actually help him. And if we hadn't gotten good data, then the whole thing would have fallen apart. I would have been almost like embarrassed to go to the FDA and say, it doesn't really work in mice, but let us treat this kid anyway. Like, that's kind of a hard thing to ask. To get at your question, if anything's been underreported, it's like
the behind
those dark days. Those dark days, or in this case, dark nights of the soul, when you're like filled with self-doubt and just like, really, just hoping and praying that things are going to work out. In this case, they did. Everything did go right. Part of it's good luck, perhaps, but I think a lot of it's a testament to, just the extraordinary efforts everyone involved in this endeavor put into it, went above and beyond to make sure that things went right.
Oh, wow. There's goosebumps. Listen, I think pretty much everyone listening to this who's ever stepped foot in a lab can identify with those dark nights of just hoping
I've spent my fair time in the lab, and I've pulled my all-nighters in the lab. Like, I'm no stranger to that. Still spend time in the lab when I can carve out the time. But here, like, the stakes are just so much higher. That's what really struck me. Like, certainly I've been, like, anxious about data. Like, I did an experiment. I put a lot of time into it. I'm hoping that, I get good results. Like, we all know that feeling, right? And often it works, but a lot of times, and maybe more often, it doesn't work. And that's just part of the practice of science. The stakes are just so different here. It's like, oh my gosh, like maybe this is exaggerating, but like, this kid's life depends on whether this experiment worked. It's not really an experiment, but like on whether the data looks good or not. It's like, oh my gosh, like I didn't really anticipate or expect that going into this whole thing.
Right. Yeah, I think that translation from, like you said, cells in a lab to someone has to make a decision of whether to put this in their body and change their whole lives. Like, sometimes I think we forget about that. But that's what it's all about.
This is a baby. Like, he can't consent. He has no idea what's going on, right? So
the pressure of the parents.
So I mean, they're just amazing people. That they put their trust and faith in us, just like, overwhelms me when I think about it too deeply. Because it's a huge thing to ask and expect them to actually want to do, given that this was something that had never been done before. And I guess the other aspect of this that has not been well reported, because no one asked.
Well, let's hear it.
Is after we treated him. It's that period where you're looking for tea leaves that something worked, because you don't really know how quickly it's going to work or how well it's going to work. And part of the issue here is because we came up with a repeated dosing strategy. So that's not something you can do with viral vectors, right? You give it once and then that's your only shot on goal. And so you start low because you have to, but your tendency is going to be to try to maximize what you can get out of it. We didn't have to take that approach with lipid nanoparticles. We could give them again and again. We knew that, and we worked out with the FDA a strategy by which we could safely do that. We spaced it out at a minimum of 3 weeks because we knew the lipid components, at least in monkeys, cleared out of the body. We could document that in our toxicology study, and they were satisfied. That's reasonable. If it's 99.5% or more gone by 2 weeks after you've dosed the monkey with a very high dose of drug, then it's a pretty good bet that if you give a low dose of drug to a human being who's actually similar size when you come right down to it, right? It's like a handful of kilograms. And you're giving a much smaller dose, and you're giving it 3 weeks, that, the drug's going to clear out the system, and it's totally fine to give another dose. So we started with a very, very low dose, almost a homeopathic dose, to be honest, because we had some confidence there would be a little bit of editing, because when we used that same dose in the mouse model, there was a little bit of editing. So at least there was target engagement, but not necessarily much expectation that we're going to see much efficacy. I wasn't expecting it. Becca, my partner in all of this, maybe she was expecting it. She doesn't have as much experience with LNP drugs as I do. Now I'd say she has as much experience as anyone in the world, having overseen 3 dosings of a patient. I've been in this game for a while, and so with other drug programs, I've had some exposure to this stuff. And God knows what was going through the parents' minds. I'm sure they were hoping that get 1 dose and then excellent results. And so I wasn't expecting much, but you're still hoping, right? You're still hoping. Yeah. And so, you wait a few days, and you don't take those few days seriously, because it takes time for the drug to work. But at the same time, you're still following things very closely, just looking for even the slightest bit of evidence that something's happening. It's the same in the lab with just, standard experiments. If you're doing a time course and there's some visual thing you can look at, it's like, I'm looking at those cells every single day, even if I'm pretty confident nothing's going to happen yet, because you just want some assurance that you're going to have you're going in the right direction or whatnot. And it's the same thing here, but it's escalated to a whole new level, right? The stakes are so much higher. And so, we didn't expect much the first few days, but after about the 3rd or 4th day, we start looking seriously at ammonia levels. That's the biomarker, but also the causal agent. I guess when the ammonia levels rise to a very high level, that's what injures the brain, and that's what you have to try to keep in control when you have the disease that he has, a urea cycle disorder. They can't process ammonia clear from the body. You can also look at other amino acids. Another one that we look at is glutamine, which has rough correlation with ammonia. And so Becca and I got into this pattern. It was very interesting, because we're checking these things daily, but because of the way the assays are done, ammonia would come in the morning, and glutamine would come in the early afternoon. And it just so happened a few days after KJ received his first dose, I actually went to Ireland for a gene editing conference, for a Keystone conference. So I wasn't even on the scene, and there was also this time difference. So what for her was first thing in the morning, early in the morning, 4 a.m., 5 a.m., and then early afternoon. For me, it was more late morning, early evening type thing. And so because I'd been awake so much longer, it felt I was more impatient and waiting, when is it going to show up? In my email or whatnot. But I think for both of us, our days have sort of, even now, have become organized around those 2 measurements. And when they come back, it's okay, the morning lab value, what is it? Okay, then you find out, and you're either really happy or not as happy or whatnot. And then you do it all over again later in the day, and then the next day comes, and you're kind of tracking these things. And it's a really interesting way to live. And as a physician, I take care of lots of patients, right? It's not this idea of tracking lab values is foreign to me. It's just, but somehow we became so invested in this one case that it just came to dominate our lives in a very interesting way. So anyway, I was in Ireland, and so we're tracking these, and then after about 3 days, Becca says, it's interesting. The glutamine's lower than I would expect it to be. It's maybe it's just a spurious value. And the ammonia was fine. Okay, the next day, and the ammonia came first. Ammonia's fine, and waiting for the glutamine. It's still low. But maybe it's some after effect of getting a large lipid load or something we just didn't anticipate. Something you need to give it some time to equilibrate. But then day after day, it was glutamine still seems low. Something's going on here. So at that point, we said, all right, let's start giving him more protein. At this point, his entire life, he'd been on a protein-restricted diet, because protein is what's toxic. It's broken down, ammonia, et cetera, et cetera, et cetera. We said, what happens if we challenge him a little? Mildly increase the amount of protein. And we did that one day. The glutamine remained down. And then we did it again. And then, and I'm in Ireland for a week-long conference. This is just unfolding all the time. And each day it was like glutamine's still down, or at least in the normal range. And it's like, we're kind of celebrating,
Yeah.
And then it happened again the next day, and then the next day. It's like, wow. And then before we knew, we were actually at the full amount of protein in his diet, which he had never tolerated before in his life.
Yeah.
It's like, really feels like we did something. I'm not sure exactly what. I have no idea how much editing there was, but it sure feels like we did something.
Yeah.
And, so like went a couple of days on full protein and looked great. The lab values, I mean, he looked great from what Becca told me, but just looking at the lab values, this was pretty impressive. Very different from what it had been before, the treatment, the months leading up to it. And then, so at that point we said, okay, well, we can't really raise the amount of protein anymore, although it is true that as Americans, we eat way too much protein in our diet compared to what we actually need, to be fair. So our normal diet is actually a high protein diet. Right? So I wouldn't say his was a normal diet, but it was the recommended dietary allowance of protein he was getting every day for a child of his age. So the other thing that you keep patients like this on chronically is a scavenger medication that helps to, bind up the ammonia and get it out of the body. It's not the best. It's not. You have to take 3 times a day, et cetera, et cetera. But it helps. And he was like on a large dose of it. So then we started weaning it down, like just hoping, okay, like will we continue to see like progress, like even though we'd given him a very tiny dose and there's no reason to think that worked really well. It's like did we actually fix it? Like, is that possible? Or are we going to hit the ceiling? And it turned out we very quickly hit the ceiling. We brought it down 10%, another 10%, and then the glutamine really started to rise. And this, so it's like, okay, so he had some editing. It seems, we think.
Yeah.
We don't know for sure. Still don't know for sure. But we're pretty suspicious because something changed.
Yes.
And it beggars the imagination to think, oh, he just spontaneously changed just on the day that we happened to dose him by total coincidence. Formally possible, but really
Yes.
doesn't seem likely. And so kind of crashed down to earth. We're sort of getting increasingly elated. Oh my gosh, this is a miracle. And then then reality sets in. Okay, good.
Yeah.
But it's all still very, very good, right?
Yes.
Okay, and then we wait some more time, and then he actually gets sick. He gets I think a cold, which is not a big deal for the normal person, right? The typical person. We don't even think twice. We feel crummy, but kind of passes. For a kid like him, that can be devastating.
Yeah.
Right, because that kind of stress, even a common cold or a stomach bug, can cause the ammonia to surge and call what we call a metabolic crisis, and that's when you get the injury to the brain. And if it's really severe, can go into coma and die. Right, so you're terrified when that happens. But even despite being sick, his ammonia didn't really budge. He looked fine, right? So all these signs, tea leaves, if you want, that things are heading in the right direction, that there's improvement. But the protocol said, okay, go 3 weeks, and then at that point you have the possibility of giving a second dose. And it wasn't Becca, it wasn't me deciding who would give the second dose. Becca had actually pulled together a clinical oversight committee and a multidisciplinary committee that had metabolic experts, that had liver transplant folks, because they're in the mix because if things go really bad, then liver transplant is certainly on the table if you can actually find a match. What we call the gene team, people who are sufficiently experienced in clinical trials of gene therapies, typically AAV gene therapies, not really gene editing therapies, since that's so new. And this, I think, is pretty sure this is the first time a gene editing therapy is given to a child at CHOP. Not in the world. No, that's not true. I would say a gene editing therapy to a child, this would be the first one. Adults have gotten it. Several hundred adults have gotten them, but I think this would be the first child, as far as I know. And even ethicists, right? So really thoughtful, a group. Becca would present the information, the data, this is what's happened, these are what the ammonia levels have been, this is what the glutamine levels have been, this is what we've been doing with the protein intake and whatnot. And they came to the decision, okay, do a second dose. And it's a higher dose. It's still a pretty low dose, but it's a higher dose, right? A dose escalation. And so we give it to him. And he's already on a full protein diet, so there's nothing to add there, right?
Yeah.
So he's already different from what he was before. But after a while, we start weaning down again, and it actually looks like we're able to wean it down, and he still remains stable. Again, we couldn't wean it down all the way, but we could wheel it down a good part of the way.
Yeah.
But again, day by day, you're perseverating, what's the ammonia level?
Yeah.
What's the glutamine level?
Yeah.
And 2 times a day. You're just getting like in this pattern and you know, hoping for the best. And you know, some days it looks really good, and you're like, oh my gosh. And then some days it like feels like it's a step back. It's like, I did not expect that.
Yeah.
This was like a whole new level of stress I'd never experienced. Despite being a physician who's taken care of many patients, like just as I said before, I've never been so invested in just one case. And I'm an adult cardiologist, so the idea of like taking care of an infant is, you know, a little bit foreign to me. I've been taking care of infants since I was in medical school. Perfectly lovely, and I didn't mind. But you know, somehow I just became an adult cardiologist.
Yeah.
You know, taking care of 70-year-olds who have heart failure and don't want to take their medications. Right? It's a totally different context.
Yes.
Yeah, you just kind of have to like plead with them and wheedle with them. I guess maybe that's not that different from pediatrics and kids, but so it was an unexpected experience. But here we are. You know, it's been a few months since he got the first dose, and he's doing well, and he's hitting his developmental milestones. He's gained a lot of weight. He's like indistinguishable now from any other kid his age, I would say. So I think we've done well by him.
Yeah.
But man, there was it was like topsy-turvy. It's like. Oof.
Yeah. Well, I think for me, what you're highlighting too is just the continuous need for transparency and ongoing education, especially as these treatments become, hopefully, more widespread, just to set those expectations that, although in a lot of ways this isn't a miracle, right? You can't necessarily expect things to change. You don't know what's going to happen. You can't expect changes necessarily overnight. It's those small moments across many weeks.
Yeah, and since you know, starting this adventure, you know, I've talked to other investigators who have done things not exactly like this. This is the first time, you know, like a personalized gene editing drug is going to a patient. But you know, the first time a customized ASO was made for a patient, what that was like. Yes. And there, it actually took much longer because you're slowly escalating the dose over the course of weeks to months. So for us, it was like, we think it's going to start working within days. So we're actually in a fortunate position. Like, I can't imagine what the stress of like tracking it over weeks
all what
and
you
looking.
Experienced.
But spread out over time. Right?
Yeah.
And the same with like CAR T immunotherapy, like, you know, given to a child. And there it's different. Like, if the effect happens, it happens pretty quickly, and then so you know. But what you're really like monitoring and like praying doesn't happen is recurrence of the cancer, and that again is like months and months and months before you start to feel comfortable. Okay, and there's no point where you can actually like truly say, okay, I don't have to think about it every day. I'm like done, because there's always a chance it might diminish over time, but there's always a chance it's going to recur. So how does that feel? I can't even imagine having gone through what I went through. Like it must be like 10 times worse. So I have a real respect for the investigators, the clinical investigators who try these newfangled genetic therapies or cellular therapies. And
well, now you're one of them.
Now I'm one of them, Lucky me.
Well, congratulations again. Thank you so much for joining us and for giving us a peek behind the scenes.
My pleasure.
And the science and the emotion that goes into this. And we can't wait to keep up with KJ and hopefully see more success stories like this next year.
Well, great. Thank you for having me.
Thank you.